Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 6, Permutations, Combinations, and Binomial Expansion, brought to you by Vitan Sir. In the previous tutorial, we discussed the first question with 5 sub-questions of the exercise 6.3 regarding the concept of binomial expansion. Now, in this tutorial, we are going to continue with the remaining questions from the exercise 6.3 and complete it. Second question, obtain the values using binomial expansion. Here 3 sub-questions are there, and this is a bit of a different kind of sum. The question is root 5 plus 1 whole raised to 5 minus root 5 minus 1 whole raised to 5. That means two separate expansions are given, and after finding two separate expansions, we are going to subtract them. This time I am going to calculate expansion vertically like this. So first of all, we will take the first term, that is root 5 plus 1, and we will expand this. We have the power 5, so our coefficients will be 1, 5, 10, 10, 5, 1. The first term is root 5, so root 5 with the maximum power 5, then 4, 3, 2, 1. The second term is 1 with minimum power 0, then 1, 2, 3, 4, 5. Nothing new here. This is something which we have already done a lot of times. And because there is a positive sign in between, all of these will add into each other. All of these terms will add into each other. Now, negative sign here. We will start with the expansion of second value. Again, because the power is 5, it is 1, 5, 10, 10, 5, 1. With first term root 5 with the maximum power 5, then 4, 3, 2, 1 and 0. Similarly, the second term is 1, so 1 with the minimum power 0, 1, 2, 3, 4 and 5. Now, because between these two values negative sign is there, the first will be positive and then alternatively negative, positive, negative, positive, negative. Now this is the completion of the expansion of both the terms, but because there is this negative sign in between, our rule is that whenever there is a negative sign in between, we inverse these signs. That means because this term is positive and there is a negative sign, this term will become negative. Similarly, this negative will become positive, negative, positive, negative, positive. So this way I have to show some extra signs here to change them. So now we will ignore these signs, and these are the final signs. Now look horizontally. This is 1 into root 5 raised to 5 into 1 raised to 0, and these two terms are similar. All of these terms are positive while some of these terms are negative. That means if I take this term and subtract this term from here, this will become 0. So I am going to cancel them out. Similarly, both of these are positive. Ignore this sign. This is our final sign. This plus sign is the final sign here. So these two terms are same and they are to be added. So we will let it be right now. Next, this is a positive term and this similar term here is negative. So we are going to cancel it out. Similarly, these are positive terms. Let it be. Again, 5 root 5 raised to 1, 1 raised to 4, and 5 root 5 raised to 1, 1 raised to 4 are similar terms with negative sign in between. We will cancel them. Last terms both have positive signs, so let them be. That means out of these two expansions, 1, 2, 3, 4, 5, 6 terms have been removed, and the remaining terms are 5 into root 5 raised to 4 into 1 raised to 1, 10 root 5 raised to 2 into 1 raised to 3, 1 root 5 raised to 0, 1 raised to 5. And if you see, the same three terms are also here. That means this and this will be added. Similarly, because this term has been repeated twice, this term also has been repeated twice, this term is also here. That means these are a group of similar terms. So one group, two group, three group. There are three groups of terms which are similar. So rather than writing down all the six terms, we will only write three terms and then multiply these three terms with 2. That means if I write this term and then multiply it with 2, I will get the total of these two. So first term, then plus, I will write this term, and because I am multiplying it with 2, I will get the answer of this total. 10 root 5 raised to 2, 1 raised to 3. And similarly, I will write down the last term, 1 root 5 raised to 0, 1 raised to 5. So here I don't need to write all these terms. I will just write 1, 2 and 3 terms, and these 3 terms are naturally calculated by multiplying our terms with 2. Next, I am going to simplify this bracket here. 5 into root 5 raised to 4. Now, previous tutorial I explained that if the power is 4 or any power is there, and I also have a square root, then I have to make half of the power. So right now power is 4, the half of 4 is 2. So 5 raised to 2. So root 5 raised to 4 is equal to 5 raised to 2, that is 25. So 5 into 25 plus into 1 plus 10. 2 is the power and root is there, so half of 2 is 1. So 5 raised to 1 is just 5. So plus 10 into 5 into 1, and then 1, anything raised to 0 is 1, and 1 raised to 5 is 1. So 1 into 1 into 1. Next, I am going to simplify this. 5 into 25 is 125 plus 10 into 5, 50 plus 1. So the total of these three values is 176. Therefore, 176 into 2 is 352. That means using the binomial expansion, if I expand these two terms and find its answer, the final answer will be 352. So this is how you calculate these kind of sums. We have two more sums which are similar to this. Root 2 plus 1 raised to 6 plus root 2 minus 1 raised to 6. First of all, we have to write down the first value here. The power is 6, so the coefficients will be 1, 6, 15, 20, 15, 6, 1. First term is root 2, so root 2 raised to 6 raised to 5, 4, 3, 2, 1, 0. Second is 1, so raised to 0, 1, 2, 3, 4, 5, 6. And because there is a plus sign in between, all the terms will be added. Next, we have positive sign between these two values, so plus, and because there is a positive sign, we will not be changing the signs of the second term. In the previous question we changed the signs of the terms because there was a negative sign in between, but right now it is a positive sign, so we are not going to change the signs. So I have not kept any space here. Next, because the second term has a power 6, it is coefficients 1, 6, 15, 20, 15, 6, 1. Same thing, whatever we have written here, the same thing we have to write here also, because our terms are same. The only difference is the sign, and because signs are different, in the first value all were positive, in the second value alternate values, alternate signs will be there, positive, negative, positive, negative, positive, negative, positive. Now positive are added, positive negatives are cancelled. You can see these terms are same. Okay, we can only cancel out the similar terms, we can't cancel out not similar terms. Here these terms are same, positive, negative, they will be cancelled. Similarly, this term will be cancelled with this term. It is very necessary that you write them side by side, it will be easier to cancel them out. So this way these terms we have cancelled. We are left with one set of similar terms, two set, three set and four sets of similar term. Because these are a set of two terms each, I am going to start by writing down single terms and then multiply them with 2. So I don't have to write both the terms, I will just write one terms, add them and then ultimately multiply them with 2. So here first will be 1 root 2 raised to 6, 1 raised to 0 plus 15 root 2 raised to 4, 1 raised to 2 plus 15 root 2 raised to 2, 1 raised to 4 plus 1 root 2 raised to 0, 1 raised to 6. Next, I am going to simplify this. How? Root 2 raised to 6, that is 6 upon 3. So 2 raised to 3 will be 8 plus 15 and 4 upon 2. So 2 raised to 2 is 4, and then power 2 and root, so it's just power 1, so 15 into 2, and anything raised to 0 is 1, so everything is 1 here. Next, I'm going to find the multiplication and then add 8 plus 60 plus 30 plus 1. So when you add them up, you get 99. Oh, sorry. When you add them up, you get 124. And therefore, your final answer is 198. Sorry, my mistake. You get 99, and then the final answer is 198. Third question, root 5 plus root 3 whole raised to 4 plus root 5 minus root 3 whole raised to 4. Here both the values are in roots, but we have to follow the same system here. The whole bracket, because the power is 4, the coefficients will be 1, 4, 6, 4, 1. First term is root 5 raised to 4 raised to 3 raised to 2 raised to 1, 0. Second is root 3, so with the minimum power 0, 1, 2, 3, 4, and because there is a positive sign, all of these terms will be positive. Then there is a positive sign in between, so plus, and because there is a plus, we are not going to change the signs of these terms. Next, root 5 minus root 3 whole raised to 4, so power 4, the coefficients will be 1, 4, 6, 4, 1. First value is root 5, so root 5 raised to 4, 3, 2, 1, 0. Second is root 3 raised to 0, 1, 2, 3, 4. Always remember these values are inverse. The first term starts with maximum power, ends with 0. Second term starts with 0 power, ends with the maximum power. And because there is a negative sign in between, first will be positive, then negative, positive, negative, positive. Now once again positive positive are added, positive negative are cancelled. So once again positive negative are cancelled, and we are left with 1, 2 and 3 terms, and we will multiply the total of these 3 terms to get final answer. So bracket into 2, the first is 1 root 5 raised to 4 root 3 raised to 0, then second is 6 root 5 raised to 2 root 3 raised to 2, and 1 root 5 raised to 0, root 3 raised to 4. So we are going to add these terms and then multiply them with 2. Now root 5 raised to 4, so 4 upon 2 will be 2, so 5 raised to 2. So 1 multiplied by 25 multiplied by 1. Now here plus 6, and root and squares will be cancelled, so 6 into 5 into 3. And lastly again plus 1, anything raised to 0 is 1, and 4 is the power, removing the root, power will be 4 upon 2, just 2, so 3 square is 9. Multiply these values and you get 25 plus 90 plus 9, and your total is 124, and when you multiply it with 2 you get 248. So my dear students, these were the 3 sub questions of the main question number 2. These kind of questions can be asked for 4-mark questions in your exam paper, and these are pretty famous and pretty important kind of sums, so pay attention. But as I told you guys earlier, this year, that is in the academic year of 2021, this concept has been cancelled, but I have prepared this video for your information purpose. So don't worry much about it. This will not be asked in your examination currently, but in future years it is possible to be asked. Moving on with the question number 3, expand 1 plus x raised to 5. It's simple, and verify by putting x is equal to 1 on both sides. Now let's see. First we are going to expand 1 plus x raised to 5. So because power is 5, my coefficients will be 1, 5, 10, 10, 5, 1. First term is 1, so 1 raised to 5, 1 raised to 4, 1 raised to 3, 2, 1, 0. Second term is x, so x raised to 0, 1, 2, 3, 4, 5. Next, because there is a positive sign, for plus, 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 plus. Now I am going to simplify this. In the first value, 1, 1 raised to 5 is 1, anything raised to 0 is 1. So it's just 1. Next, 5 multiplied by 1 multiplied by x is 5x, plus 10 multiplied by 1 multiplied by x square is 10x square. Similarly, 10 into x cube plus 5 into x raised to 4. I am just ignoring these 1 values because multiplying or squaring or cubing 1 doesn't matter, it's always 1. And last value is 1 into 1 into x raised to 5. Now this is the expansion of 1 plus x whole raised to 5. What we need to do is we need to put 1 on both the sides. That is, we need to put 1 here and here. So 1 plus 1 raised to 5 is equal to 1 plus 5 bracket 1 plus 10 bracket 1 square plus 10 bracket 1 cube plus 5 bracket 1 raised to 4 plus 1 raised to 5. Now we know that 1 plus 1 is 2 raised to 5. 1 will be 1, 5 into 1 is 5, 10 into 1 square is 10 itself, 10 into 1 cube is 10, 5 into 1 raised to 4 is 5, and 1 raised to 5 is just 1. 2 raised to 5 is 32, and when you add all these values you get 32. That means we have proved that left hand side is equal to right hand side. We were just supposed to verify whether directly putting the value or expanding them first and then putting the value gets us the similar answer or not. That was the purpose of this sum, and we get one similar kind of a sum to practice it better. 1 plus a raised to 6 and verify by putting a is equal to 2 on both the sides. So 1 plus a raised to 6, because the power is 6, my coefficients will be 1, 6, 15, 20, 15, 6, 1. The first term is 1, so 1 raised to 6, 5, 4, 3, 2, 1, 0. A raised to 0, 1, 2, 3, 4, 5, 6. And because there is a plus sign, plus, 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 plus. Next, 1 into anything raised to 0, 1, plus 6 into, just forget about this 1 from everywhere. 6 into a, 6a, 15 into a square, 20 into a cube, 15 into a raised to 4, 6 into a raised to 5, and a raised to 6. Now we need to put 2 on both the sides. So first we will put 2 here, so it will be 1 plus 2 raised to 6 is equal to 1 will be 1, 6 into 2 plus 15 into 2 square plus 20 into 2 cube plus 15 into 2 raised to 4 plus 6 into 2 raised to 5 plus 2 raised to 6. Simplifying, 3 raised to 6 is equal to 1 plus 6 into 2 12 plus 2 square 4, so 15 into 4 plus 20 into 2 cube 8 plus 15 into 2 raised to 4 16 plus 6 into 2 raised to 5 32 plus 2 raised to 6 64. Next, I am going to keep it as it is because I need one more step here. 1 plus 12 plus 15 4s are 60 plus 28s are 160 plus 15 into 16 240 plus 6 into 32 192 plus 64. 3 raised to 6 is 729, and when you add all of these value up you get 729. That means your left hand side is equal to your right hand side. So we have proved that the expansion of our terms is a valid method. It gives us the same answer. Okay, so with this the chapter number 6 ends. We have completed the permutation, the combination, and the binomial expansion. Thank you very much for being with me throughout this chapter. If you have liked this, please give me a big thumbs up. If you are new to this channel, subscribe it. If you have any feedback, put it in the comment box below. Let me know your thoughts on how well I have prepared this. And next time I will start with chapter number 7, that is sampling methods. It's a pretty simple chapter with a lot of theoretical topics, and we will do that with a lot of entertainment. Thank you very much once again, and see you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.